Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from mechanics, and this particular question belongs to paper 9709/41 for the session October November 24. Question number 5 says a particle A is projected vertically upwards from a point O with a speed of 80 meter per second. 1 second later, a second particle B with the same mass as A is projected vertically upwards from O with a speed of 100 meter per second. At time t second after the first particle is projected, the two particles collide and coalesce to form a particle C. Show that t equal to 3.5. So t means actually the time taken by particle A. We should not forget that in case of collision, if two particles collide with each other, they must collide they must collide at the same moment as well as at the same height from the ground. So this is the fundamental concept. Remember, in case of collision of two particles, surely they collide at the same moment as well as at the same height from the ground. So considering this concept, we are starting our solution. As we have already decided that the concept we are going to apply is both the particles must collide at the same height from the ground. So let us find the height, and for height I means displacement or distance. We know the concept is Schubert formula. Schubert formula is going to be applied. First of all, we will start with the particle B because B was projected later on. So SB, Schubert formula is going to be applied. SB is equal to UT plus half AT squared. Well, equal to initial velocity of B. Let's see, initial velocity of B was 100 meter per second. It is just 100. So 100 T. And look at this, the particle was projected upward, whereas acceleration due to gravity is acting downward. That's why this direction of this acceleration is negative. Okay, so it is going to be half. Acceleration due to gravity is actually nothing but 10 and t square. So finally, what are we going to get? It is going to be negative 5t squared plus 100t. This is the displacement traveled by particle B before it collides. Then for particle A, okay, for A, the same concept. So what formula? UT plus half AT squared. Well, now we should not forget that they have told that particle B was projected. Look, particle B was projected vertically upwards from O with the speed of 100 meter per second. Okay, 1 second later. So this is the clue word. Look, particle B was projected 1 second later. Then what does it mean? Actually, A was projected 1 second earlier. That means particle A took 1 second more than the time taken by B, particle B. If particle B takes t time, look at this. This is the time taken by particle B. So surely particle A took 1 second more because A was projected. A was projected 1 second earlier. So it is going to be U. U. How much is the initial velocity of particle A? It was 80. So 80 and time taken by particle A must be 1 second more than the time taken by particle B. So particle B took t second. So surely particle A took t plus 1 second. Let me have some space just below this. Yes, I think I should continue writing over here. Let me erase this step. Yes, then it is going to be t plus 1 second more for particle A, and it is again negative because acceleration due to gravity is acting downward, whereas the particle was projected upward, so they are opposite to each other. Direction was opposite to each other. Then it is going to be negative half into 10, and time we have already described that t took 1 second more, t plus 1 whole square. Hence it is going to be 80t plus 80 minus 5 into t plus 1 whole square is actually t square minus 2t plus 1. Okay, so we can simplify this. If we simplify, it is going to be negative 5t square, negative 5t square, then minus plus 10, sorry, it is plus, so negative 10, positive 80, so it is going to be 70, positive 70t, positive 70t, and positive 80 and negative 5, so positive 75. So this is the displacement traveled by particle A, and we are not deviating from our fundamental concept that both the particles collide each other at the same height. So height, what is the height traveled by each of them? They must be equal, because our concept was that when two particles collide each other, they must collide at the same height from the ground. So this height traveled by height, I mean displacement traveled by particle B as well as displacement traveled by particle A must be equal. So we can form an equation. SB is equal to SA. SB SB must be equal to SA. Or if you wish, you can write these words over here. During at the time of collision. Okay, let me write this, erasing this. For your better understanding, for better memory, let me write this. During collision, during collision, both particles, both particles were, were at the same height, at the same height from the ground, same height from the ground, from the ground, and we have taken the ground as the reference frame. Ground, well, that means the displacement traveled by, covered by particle B as well as displacement covered by particle A must be equal. That means SB height of particle B must be equal to the height of particle A, equal to height of particle A from the ground. Okay, SB, let us write how much was SB. SB is minus 5t squared, or minus 5t square, minus 5t square plus 100t plus 100t equal to SA. SA is negative 5t square, negative 5t square Can we continue writing these on the next page? Because um, okay, let's continue. 5 minus 5t square plus 70t plus 70t plus 75 plus 75. Then from each of the sides we can dissolve this 5t square. They are of same symbol. Then 100t minus 70t. 100t minus 70t means equal to, we can write over here, or 100t minus 70t means 30t. 30t is equal to 75. Right side is having nothing but 75. Hence our t is equal to what? 2.5. 2.5 second. That means t was the time of home. Look at this. We should not forget that t was the time taken by particle B. But what did the question tell us? The question has told us to find, show that t is equal to 3.5, and t is what? At time t second after the first particle projected. So t is the time taken by particle A. Hence our t is equal to what? We have already written t is t plus 1, that means lowercase t plus 1 means 2.5 plus 1 second means 3.5 seconds. 3.5 seconds shown. Seconds. That means t was the time taken by particle B. But we are trying to find the time taken by particle A, and particle A took actually 1 second more than the time taken by particle B. If particle B takes 2.5 seconds, so particle A took 3.5 seconds. They have told us to show, and we have shown. I think you have understood that we have applied the concept of, the fundamental concept when two particles collide is they must collide each other at the same height from the ground, as well as at the same moment they have been projected from. Okay, after that the question number B says, find the height above O. O is the ground at which the particle collides. So any of the equation we have, they have told us to find the height. Already we have found height. Any of the equation will work. So height is equal to, we can write height equal to height. What is the height of any of the particle? Both of the heights, I mean both of the particles reached the same height. So we can continue from SB. Okay, I mean particle B. Particle B collided at the height of minus 5t square plus 100t. So we will write minus 5t square minus 5t square, and we know the value of t has already been obtained. Look at this. Particle B took 2.5 seconds. So the value of t is 2.5 seconds. 2.5 plus 5t square, t square plus 100 into 2.5. Well, let us see how much is this. If we subtract 5 into 2.5 square from 250, so 250 minus 2.5 square means actually 6.25. Okay, it is going to be 6.25. So 6.25, so 30.2, so it is 218. 218.75 meters, 75 meter. So this is the height the particles collided each other. Well, so that's all about the solution to these two questions. I mean, two parts of this question. Then let's move on. Don't get confused. The height, if you assume that why did we apply the height of particle B, why not A? Actually, it's all the same because both of them collided at the same height. If you apply this equation, you must get the same value. Okay. So let's move on to the next question. The immediate next question says, yes, over here, the question says find the time from A being projected until C returns to O. Well, for finding time, we always opt for the Shubert formula. And for Shubert formula, we should know the initial and final velocities. Let's see whether we do have initial or final velocity or not. If we go back to the question, look at this here. The question is given that they have collided at the height of 218.7 meter. I think it was 218.7, it's 75 meters. Okay, it should be point here, there should be a 5 as well for more appropriate result. Let us write 75 meters. Well, but we don't know the final velocity, the velocity that we know the initial velocity when they were projected, but we don't know the velocity just at the time of collision. So for this, if two particles collide each other, we should know the initial, I mean the velocity before the collision and after the collision. So the velocity before the collision is unknown to us. First of all, we'll have to find the initial velocity, I mean the velocity before the collision. And we know that here the initial velocity for A was 80, whereas initial velocity for particle B was 100 meter per second. So applying these, we are going to find the final velocity, I mean the velocity just at the time of collision, and individually we'll have to find them. So let us find the final velocity of A. We can write just over here. Okay, VA. Final velocity means the velocity just before the collision. We know the formula is U plus AT. Okay. So initial velocity, we know the particle A was projected with 80 meter per second, and acceleration due to gravity is negative, so it is 10. And T was, we have not forgotten that B took the, I mean T was 2.5, 2.5, sorry, this is particle A, initial velocity was 80 and particle A took 3.5 seconds. We have not deviated from the question. Look at this, we have already written here that A took A took 3.5 seconds. Okay, so we will have to write 3.5 over here. Well, from 80, if we subtract 35, it is going to be 45. So 45 meter per second was the velocity of a particle A before collision. Now velocity of particle B just before colliding. So the same concept, u plus 80, and initial velocity of V was 100 meter per second, and acceleration due to gravity is negative 10, and time taken by particle B was 1 second less. It was 2.5 second. So 100 minus 25 means 75. That is B to 75 seconds. I mean, velocity of B before collision was 75 meter per second. 75 meter per second. This is the velocity just before colliding. Well, now we should know the velocity after collision also. So how to find the velocity after collision? We know the concept is the conservation of momentum. Through the conservation of momentum, we can find the initial final velocity of two particles. So let us apply the concept of conservation of momentum. So conservation of momentum is what? MA, let me write it after zooming it out. We know the concept of conservation of momentum is MA, not with this ink. Let me change the color of the ink. It may be this. Okay, so MA into UA plus MB, mass of particle B, into initial velocity of B is equal to mass of particle A into final velocity of B, I mean final velocity of A, plus mass of particle B and final velocity of particle B. Now we are going to apply the values we do have. What are the values we have? We have the values of, for A, look at this. Here the mass of each of the particle was same. Look at this. Here it is written. Look, mass of the particle, each of the particle was same. Look at this. With the same B, with the same mass as A. Mass is same. So we can avoid and discard mass from each of the sides. Every quantity is having same mass. So we can just avoid this from every side. So mass will go away from everywhere, and there remains initial velocity of A. Initial velocity of A has already been obtained. We have got it is 45. Initial means the velocity just before collision. Don't think that the velocity when it was projected, that is not the initial velocity. From conservation of momentum, the concept is the velocity just before collision and the velocity just after the collision. Well, so the velocity before the collision was 45 plus the velocity before the collision of particle B is 75 equal to, look, after the collision both of the particles, this is also part of the information, that both the particles collide and coalesce. So this is a coalesce. Coalesce means both the particles have become the same particle. So it is actually VC. Now it has become BC. This one is also VC. That means both the particles have become one particle, which has been termed as C. So VC to VC. 2VC is equal to what? 45 plus 75, that is 120. Well, hence our velocity of particle C means after the collision, the velocity of particle was 60 meter per second. 60 meter per second. Okay, this is the velocity of both the particles combinedly just after the collision, and it will be termed as actually initial velocity now onwards. Okay, what can we assume and understand from this velocity? Look at this. After the collision, velocity of the particles or combined particle is positive. Look at this, is positive velocity. That means the scenario is the particles were, suppose A and B, A and B together meet at this point. Now this is particle C. Okay. Then as after the collision velocity is positive, so it went up and then it came back to the ground. And when it reached the highest point, then there was no, velocity was zero when it was changing its direction from up to down, upward to downward. So I think you have understood here. This is, let me erase this. Particle C is over here, means A and B combinedly has become particle C. Then C went up, reached the highest culmination with a velocity of 0 because it came to rest at the highest point. Then it came back to the ground. This is the ground or O, whatever you tell. It came down vertical downwards. Well, then what should we do now? They have told us to find, our question is to find the time. We have already known that C took, how much time was taken by C to reach at this height? At this height they have taken total 3.5 second. 3.5 second we have come to know from the previous question. Let me show you that here what was the time taken by particularly, it was 3.5 second. 3.5 second was taken for reaching until this height before becoming C. Then we will find what is the time taken by this combined particle to reach the highest point, or when it came to rest. So we know when a projected particle reaches its highest point, then the velocity is zero. It comes to instantaneous rest. So we will write here the time taken by time time taken by C when it came to rest. So when a particle comes to rest, surely its final velocity is zero, and we are going to apply frequently the Schubert formula, Schubert concept. So V is equal to U plus 80. We have already decided that the particle C came to rest when something is projected upward at one stage, at one instant it must come to rest. So highest point final velocity is 0. Then initial velocity has already been obtained. We have found here initial velocity of particle C was 60. So it is going to be 60 plus, it is not plus at all because acceleration due to gravity was, acceleration due to gravity is acting downward and velocity was positive, so it direction is different, that's why it's negative 10 t. Hence our t is going to be 6 seconds. T is equal to 6 seconds because 60 divided by 10 is 6. So look at this. Let us write the time taken to reach here. It took how much? 6 seconds. 6 seconds. So first until when it reached at the point of collision, then it took 3.5 seconds. Now it has taken 6 seconds. Let me change the ink. On changing the ink, I am going to rewrite them. Okay, let me erase this. So first both of the particles took, I mean A took 3.5 second. Here it was 3.5 second. then it took c took 6 seconds to reach the highest point. Then we will find that how much was the displacement or height before the particles comes to rest. So we can write distance traveled by c, distance distance traveled traveled by c before before coming to rest, before coming coming to rest. Okay, and we know the displacement distance or height formula is sc is equal to ut. So what formula? Ut plus half a t square, well, is equal to initial velocity was, we didn't forget that our initial velocity was 60. Look at this, after collision it was 60. So 60 into time was taken 6 seconds, we have obtained here, it is 6. And acceleration due to gravity was negative, so half of acceleration due to gravity was 10 and t was 6 seconds, so 6 squared. Hence it is going to be 360 minus, what is it going to be, 5 36, so 180. That means it is going to be 180. From 360, if we subtract to 180, it is going to be 180 meters. So the distance traveled by particle c was 180 meters. That means first it took 3.5 seconds to reach 218.75, might be 218.75 at this point. Then it took 6 seconds to reach the highest point, then directly it came down. Okay, it came down directly to the ground. So total height, how much is the total height now? 180 meter plus it was, here it was how much, 190 118 or 218.75 minutes. So what is the formula? Again we are going to apply the same concept, sc. When it came down, we will write sc, yes, sc sc is equal to sc is equal to ut plus half a t square. Okay, let me erase this. Yes, half a t square. So sc we have already calculated. Until before collision they traveled, from the previous page we can see they traveled, this was the distance they have traveled, 218 point, so 218.75 meters plus then before coming to rest they have traveled 180 meters, 180 meters equal to initial velocity. Definitely when it was coming downward, initial from rest, initial velocity was 0 plus half a t square. Half. Now look at this, direction of acceleration will not be different because the particle was moving downward. At the same time, acceleration due to gravity was also acting downward. So the direction is same. There will be positive symbol, half a t square. A t square. T is to be obtained. Okay, t square. So what is it going to be? Let me find some space to write this. I don't have any space on this page yet. I will have to continue. So total on the left side, it is going to be 218 plus 180, so 398 point 398.75 7 and 5 equal to, it is going to 5t square, 5t squared, 5t squared. Well, then let me write just over here because I don't have sufficient space to continue writing over here. If we write, so this 5t square, or t is equal to mm, square root over what, 398.75, 398.75 over 5, 300 398.75 over 5. Let us find our time. Is It is going to be square root over 395.75 over 5 equal to 8.9, 8.9 seconds. Now we will go back to the question. What did the question tell us to find? The question has told us to find the time taken. Look at this, time taken from A being projected until C returns to O. Let us see what is the total time. First, it has taken 3.5 seconds before collision. After collision, when it reached the maximum height, it took 6 seconds. Now we have found that it took 8.9 seconds to come down to the ground. So it is 8.9 seconds. 8.9 seconds. So total time starting of A from the ground was what? 3.5 plus 6 plus 8.9. How much is it going to be? Let us write here. Total time, or time is equal to time taken. Time taken is equal to, first let us start with the final one, 8.9 plus, before that it took 6 seconds and 3.5 seconds, 6 seconds plus 3.5 seconds, 3.5 seconds equal to total time, 8 plus 6, 14, 14 plus 3, 17, 9 plus 5, 14, so 18.4 second. It is going to be 18.4 seconds total, 18.4 seconds, and that is the final answer. The total time taken by particle A, that means total time of the journey from the time of projecting A until the particle C touches the ground. I think you have understood. I tried my level best to clarify each of the points as much as possible on my part with this device. So first of all, what did we do? Simply, they have told us to find total time taken by the particle until C returns to O. From, look at this, from, find the time A being projected until C returns to O. That means the since the beginning till the end of the coming down of particle C, a whole of the time instant should be found. Then we have got here, I think I should change the ink of this because it is okay. If I change this ink just for few seconds, it is going to be T equal to, because there should be similar color, 398. Erasing this, I will write again. It is 398.75. Okay, 398.75 over 5. Hence, T for the final stage, T was 8.9, 8.9 second. So, how did we do them stepwise? In the first step, we have found that the time taken by C to reach the highest point. After that, we have found the time taken by C to reach the ground. And before doing this, we have already found the time taken by A and B. I mean A to reach at C. I mean at the time of collision, it took 3.5 seconds from the first question. After that, we found that C took 6 seconds. C took 6 seconds to reach the highest point or maximum height. Then C took 8.9 seconds to reach the ground. So total time taken by them is 18.4 seconds from A being projected until C touches the ground. And everywhere actually we have applied the same concept of the Shubert formula, and you may get confused at one stage where we have found the final velocity of A. This final velocity means actually the velocity just before colliding. Before collision, there is an initial velocity. This has been termed as initial velocity. So don't get confused with this one, that initial velocity was given. Look at this. In the question, initial velocity was given 80 meters and 80 meter per second, as well as 80 meter per second, as well as 100 meter per second. So these are the initial velocity. Remember, these are the initial velocity when the particle was projected. But when we apply the concept of the conservation of momentum, in that case, that cannot be the initial velocity. The conservation of momentum concept requires the velocity just before the collision and just after the collision. That's why we have found the initial velocity means the velocity just before the collision, and after that we have got the velocity just before the collision. It was 45 meter per second and 75 meter per second respectively. Then applying this, or supposing this to be initial velocity, we have found that final velocity of particle C after the collision was 60. And for the second phase, when C reached the highest point, this final velocity has been supposed to be initial velocity, because with this speed, with this velocity, it started moving onward. So thank you all for being with me, for listening to this, and I tried my level best to clarify each of the points. If it benefits you, then I will be grateful and thankful to Almighty Allah. Please earn knowledge, acquire knowledge for the betterment and welfare of the humankind. Sophie Amanillah.